this is a question in which we have been given a rhombus and they say that the length of the diagonals is 32 centimeters. So this longer diagonal AC is 32 centimeter and the shorter diagonal BD is 24 centimeter. And what we have to do, we have to find the altitude of a rhombus. So this question, according to me, would be in difficulty index, it would be 4 stars, because here the concept is that the idea of altitude. So we have heard of the altitude of a triangle, but altitude of a rhombus. Okay, so as we are highlighting the concepts before we solve every question, first concept required in this question is that in a rhombus, see, rhombus is a quadrilateral which has all sides equal, that is obvious. In a rhombus, the diagonals bisect each other at 90 degrees. So you can note down these facts. So once the diagonals bisect each other at 90 degrees, so the longer diagonal AC, we will have this as 16 and 16. And obviously they bisect each other, so the shorter diagonal will be 12 and 12. The next important concept is what is the altitude of a rhombus. So by altitude we mean height. Now see, if we take A, B, C and D as the rhombus, the altitude is the line drawn from any vertex to the opposite side. So this H would become the altitude of the rhombus. Now the third concept which we will use in this question is that since rhombus is also a parallelogram, what is it? Rhombus is also a parallelogram. The formula area equals to base into height would be applicable for the area of a rhombus as well. And the other formula which we will be using is area of a rhombus is half into product of the diagonals, half into D1 into D2. So my idea is not only to quickly give you the solutions of every question, that would actually have no value, because you have to do the next question, an alternate question, a different question, right? So what we are giving you, the concepts first and then the solution later on. So once again, quickly revising the concepts of this question. Rhombus, diagonals bisect each other at 90 degrees. A rhombus is also a parallelogram, so the area base into height will be applicable. And for the rhombus, the formula for its area is half into product of the diagonals. Now, let's quickly have a look at the solution, right? So since it's an MCQ, we don't need all the steps. So first thing is, we will find the area which is half into product of the diagonals. So product of the diagonals, first diagonal is 32 and the second diagonal is 24. Okay, this area would be equal if I take the area using the formula base into height. The main problem is, from where will we get the base, right? So for base we need to use Pythagoras Theorem. Now do you remember in the previous question we applied a small trick? Let's use that trick again. 16 is 4 times 4, 12 is 4 times 3. So in Pythagorean triplet, we have 4, we have 3. So what is missing for the hypotenuse? That is 5. So since 4 and 4, so we have a third 4. So this will be 4 into 5, that is 20. You know, it saves a lot of time. It saves a lot of time, genuinely. Believe me. Now, what happens? we have got the base. Now this side AB is 20, so in a rhombus all the sides would be 20. So what would be this side? This is also going to be 20. So the area of rhombus is base into height. We know the base is 20 and the altitude. Now what's the altitude? The height of the rhombus. Now let's quickly have a little bit calculation. We'll cancel this 2 and 32. So this will give us a 16, and we cancel this 2 and 24. This will give us a 12, and we have 10 times h. So actually h is equal to 192 upon 10. So the answer is 19.2 centimeters, right? So this would be our answer.